Welcome back, Physics 30. This is the friction lab that you are to do after you're done the friction notes and quizzes. So the purpose of this little activity is to investigate friction and measure the coefficients of friction. So static friction, the starting friction, and also the kinetic or moving friction. So first of all, an object placed on an inclined plane may or may not slide. If the object is at rest, the force of friction is opposing the tendency of the object to slide down the plane. When the plane has been tilted at a certain angle, so if we lift the angle higher and higher and higher, the object will begin to slide down the plane. Now, if the object slides down the inclined plane at a constant speed, then that means that the force of friction is equal to the force down the plane, or I often refer to this as FA, the applied force, or of course, it's equal to F parallel. The force down the plane is the same as the component of the object's weight, or Fg, parallel to the plane as shown in the figure. So of course, this is what we have been dealing with here. So this force component here is equivalent to this force component here, the applied force down the plane. The parallel component of the weight, or Fg, is described as F parallel equals, now this lab here refers to Fg as Fw, it's the same thing here. So if we take a look at how we did that previously to figure out F parallel, of course it's the opposite side. So if I use sine of theta, opposite over hypotenuse, F parallel over Fg, that's how I can figure out, this is how I'm going to figure out F parallel. Sine is equal to F parallel over Fg. If I multiply it side by Fg, I get Fg multiplied by the sine of theta will help me figure out F parallel. So over here, if I look at this section, since it's sliding down at constant velocity, my force of friction will be equal and opposite to F parallel. And a way to figure out F parallel is, of course, Fg sine theta. Okay? The perpendicular component of the weight can be described in terms of cosine. So F perpendicular, or F, the opposite of Fn, the normal force, and F perpendicular are equal and opposite, and it's the adjacent side. So cos of theta equals F perpendicular over Fg. If I multiply it side by Fg, I get F perpendicular. So over here, technically, the coefficient of friction is force of friction over Fn, but since I know that friction is equal and opposite to F parallel because it's going down at constant velocity, and also Fn and F perpendicular are equal and opposite, I can say F perpendicular here, which is Fg cos theta. And if you look at what happens here, the Fg's cancel out and we get simply sine theta over cos theta. And of course, for math, we know that the ratio of sine over cos is tan. So in a sneaky way there, we can figure out the coefficient of static or kinetic friction by simply knowing the angle at which it happens. So the coefficient of friction is equal to tan theta. So select an object on a flat board. So I have a flat board here, and I have, as you'll see, blocks. Describe the object on the surface of the board. Tape the string to the end of the object. Hang the object by the string from a spring scale to measure the weight, or Fg, of the object, because we need to know that. Excuse me. 3. Place the flat board on a horizontal surface. Hold the spring scale and, with the string held parallel to the level board, pull the object with what you perceive to be as constant speed. With the spring scale, measure the amount of force required to keep the object moving at a uniform rate. Report this procedure several times, average your results, and record this in Table 2 as the sliding friction, or kinetic friction. Kinetic and sliding friction are kind of used interchangeably here. I refer to it as kinetic. This lab refers to it as sliding friction. So we do that and we record to it over here. So we describe the object, we describe the surface that we're dealing with, weight of the object. Here's where you do it 3 times, add up, average it to get your answer. Then the force of sliding friction, so when you're pulling it level along the surface, Do it 3 times and average the results. Okay? Next. Let's see here. We have, repeat the, okay, so there we go. 4, detach the string from the object. Place the object on the flat board. Slowly lift one end of the board. Continue increasing the angle of the board with the horizontal until the object just starts to slide. So what that means is that it's just beginning to experience the kinetic, the starting friction or static friction. So the friction to get it moving initially. Now what you have to do is use the big protractor that I have in the lab and measure the angle at which the board happens. So you're going to lift the board up till the object just starts to slide. And that'll help you find static friction, the friction at which it just starts to move, and of course measure that angle. Okay, so that's what you'll be recording here. So the angle in degrees just to get it moving. And then, of course, if you figure out tan theta, it's the sneaky way of getting coefficient of friction. Next, move the object to the end of the board again and have the board flat. Again, slowly lift the end of the board while your lab partner or someone slightly taps the object. So you're tapping the object because you're trying to overcome static friction and just basically look at kinetic friction. Just angle the board until the object slides at a constant speed after it has received an initial light tap. So and of course this should be less than the previous one because it's already moving because you've tapped it slightly. So this is the idea of finding kinetic friction. Use a protractor to measure this angle and record it as sliding, or what I refer to as kinetic friction. The tangent of this angle is the coefficient of sliding friction. So there we go. That angle will go here, and then this calculation will be the coefficient of sliding friction. Repeat the experiment with the different objects so that each lab partner has data to analyze. So basically, if you work together with someone, just use the same data. Okay? From the data in table 3, calculate the coefficients of static and sliding friction. So there's nothing to really answer here because I assume that you've just calculated it over here by tan of theta for each respective static or starting and sliding or kinetic. And some of the follow-up questions. Explain any differences between the values of coefficients of static and static and kinetic or sliding friction. So you should get different answers. Which one's less, which one's more? I kind of gave a hint as to that already. 3, using the data in table 2, calculate the coefficient of sliding friction. Show your work. So for that, FF over Fn. So here we know the object weight. So if we're just dealing with sliding it on a flat surface, Fn is equal to Fg, so this is our Fn, and then our force. So using these two values here, we can get the coefficient of sliding friction, or in this case, I guess technically I've been calling sliding friction kinetic friction. So that should be a K. And then of course, are your values for the coefficient of kinetic or sliding friction in number 1 and 3 different? So in an ideal world, your kinetic friction here, or sliding friction, should be equal to the kinetic or sliding friction here. So maybe you can explain any differences that you see there. Here, number 5, you should be able to read this and figure this out. This is kind of from our very first set of notes that we dealt with, so you can read that and answer that. And this one here should be relatively easy too. And then determine factors that influence friction. Again, you can look back in your booklet if you forget. There's 2 things basically that influence friction. And then lastly, an application here. A person living in a city that rains a lot, and there's 2 different types of tires to buy. Which type should that person buy and why? So with the ideas of static friction and kinetic friction. Okay, there you have it. Be sure to ask me any questions if you run into any difficulties with this. And good luck. See you again.